Okay, this pre-algebra video is meant to be a chapter 1 summary of the main ideas. It's going to provide a variety of examples, and for every single one of them, you need to press pause and try them first, and then hit play and check yourself. So essentially what I'm going to do is I'm going to show you a list of problems, and I'm going to reveal those answers one at a time, but then I'm going to go ahead and show a workout slide for each of those if you need to understand why. Some of them may not explain very quickly, but at least I will not explain very long, but at least I will give some explanation. If nothing else, look at the steps that are shown. Just remember, make sure you try every single one of them yourself first, then press pause. Alright, so our first topic was section 1-3, where we talked about product and quotient of powers. So in this section we talked about what to do when multiplying with common bases and what to do when subtracting with common bases. So as a brief reminder, I said subtracting, I meant dividing with common bases, excuse me. As a brief reminder, when you multiply with common bases, okay, the common bases being the w's, you're going to add those. So that's going to be w to the 9 plus 5 power, okay? So I already gave away the first one. So as a brief reminder also, is when dividing with common bases, the common base being the x, you're going to subtract those exponents. So that's the hint you're going to get. Alright, so I want you to hit pause. I want you to try each of these questions. If you want, I'm going to show the answers one at a time and explain them one at a time, so it's up to you how you want to do it. But try this first one. Maybe we'll say the first two, since I already gave away the first one. Press pause. Add those exponents. If you have coefficients, if you have coefficients in front, you actually multiply them together when it's a multiplying question. So when you multiply 3 times 9, you get 27, and then add the exponents on the x. Now use that and move forward and try each of the following examples. I'm going to show each of these one at a time. So try number 3, then hit pause, try number 3, and see how you did. Okay, you get positive 20 times k to the 3rd power times m to the 5th power. Now I'm going to explain how to get that answer, so if you already know how to get it, you can fast forward past the next part. Start by multiplying your coefficients together. Negative 5 times negative 4, negative times a negative, that's positive 20. Then move on to your next letter. K to the 2nd power times k to the, if it doesn't have power, it's a 1. So add those together, 2 plus 1, that's 3, so k to the 3rd power. And then do the same thing for your m's. So this is how you'd show your work to go step by step for number 3. Now try number 4 if you haven't done so already. Press pause if you haven't done so already. And this will be your answer to number 4. If you need to understand how to do it, watch this next part. Otherwise, if you already got the correct answer, you can fast forward past this next part. Just like the last one, start by multiplying the coefficients. Positive 9 times positive 6, well, that's positive 54. Then move on to your next letter. X squared times x to the 7th, so that's 2 plus 7. So that can turn into x to the 9th power. Move on to the y's, y to the 4th times y to the 9th. So add those together and you can get 13. So that's going to be y to the 13th power. Now you'll notice z has no one to play with on this one. So that means that z doesn't get multiplied by anything. So it's just z times, technically there's a 1 over here if you need it, so it's z times 1. But z times 1 is just z. So that's why we had a z on the end. So that's our final answer for number 4. So in summary, what you'll see is these 4 questions, they offer a wide variety of all the possible ways that product of powers can be asked. So you'll notice we had simple questions with just one letter. We had questions where we had coefficients in front of our letter as well. Then we had questions where we had negative coefficients and we had more than one variable, and you just saw you go letter by letter. And then we had an example where we had coefficients, we had variables, but we even had a variable that was in one but not in the other, and we showed what to happen. So this is pretty much all the possible examples, all the possible types of questions with product of powers. Now we're going to talk about quotients. Alright, these are your quotient examples, so I want you to press pause and try the first one. I may have already given away how to do it, but at least do the first one and maybe the second one as well. Press pause. When you divide with common bases, you subtract. So 7 minus 5 is 2, so the answer is x to the 2nd power. X squared is number 5. Now as for number 6, divide the coefficients and then do the same thing with the variables. And you end up with 3w to the 9th power. 3 times w to the 9th power. Now, press pause and try number 7. Your final answer is at the bottom, and it's also the work of how to show it's right above it. Divide the coefficients and then subtract the exponents. Make sure you're able to get these two answers. Now, try number 8. Press pause if you haven't done so already and try number 8. There's your answer number 8. Now, the next part, I'm not going to explain how to do number 8, so if you already know how, you can fast forward past it. Start by dividing the coefficients, then the w's, then the x's, and then the y just gets left alone. So there's your work in between of how to get to it. Just make sure that you are subtracting those exponents of the common bases, and notice there was no y on the bottom, so we just left y squared alone. It was left as y squared. Our next section of main ideas was 1-4, power of a monomial. There are two main skills in the power of monomial section. There was the power of a power skill, and I'll show you an example of that. A simple example of that would be if we had x to the 5th power, all of that to the 3rd power. The shortcut of how we would show our work for that is, for more explanation, watch that video, but in short it was a power of a power, meaning an exponent of an exponent. That means we multiply them together. So 5 times 3. So you end up with x to the 15th power. That would be the answer to that question. That's the power of a power. That just tells you what to do when you have an exponent on the outside of an exponent on the inside. So that was a very simple example of what a power of power is, but pretty much it is that skill. You can't do power of a product if you don't already understand what power of a power is, meaning an exponent of an exponent. Whereas a power of a product is essentially a power of a monomial. It's essentially the whole thing. An example of that I'll show you. Before I do the power of a product, let's just set the rest first. Power of a power. So here I've given you 4 examples. One of them I already helped you with. So now I want you to do the rest of the examples. Press pause and try each of them. Hit pause. Multiply them together, you get 6 to the 12th power. W to the 16th power. Now I want to point out, hit pause, you haven't tried so already for this last one. So I want to point out that if you do not have an exponent on something, you can give it an exponent. You can either make it a 1, or what's going to end up happening is it's going to end up getting this 3. That 3 on the exponent on the outside ends up going there. But if you're not sure why, we can prove it by let's pretending there's a 1 right there as of now. So we show our work when we would say x to the 1 times 3 power, and then y to the 2 times 3 power. Now notice that x to the 1 times 3, that is 3. So it ended up becoming 3. So like I said, if there was nothing there, it is eventually going to become what was on the outside. And then it's going to be y to the 6th power. This is going to be the complete answer to example number 12. So now we've done several examples of power of a power. Now let's do some examples of power of a product. It's using the exact same skills of power of a power, but the only difference is there's going to be more than just one thing in here. Well, technically I gave you 2 on this one, but it's going to be a bunch of things in here. You'll have a coefficient, you'll have a negative coefficient, a positive coefficient, multiple letters, some with exponents, some without exponents. So it's literally just using everything we just did here, but actually with coefficients. And the only difference is when we have coefficients, we're going to actually evaluate them and see what they equal. So the only difference between a power of a power and power of a product is in a power of a product you have more than just one thing on the inside of the parentheses. But it's going to be the same. Everything in here, the 2, the x squared, the y to the 4th, everything in here is going to be to the 3rd power. So do everything piece by piece and then keep track. So hit pause and try this question. Press pause. So apply to the 3rd power to everything on here. Now, notice the coefficient 2 didn't have an exponent, and usually that's going to happen. Your coefficient is just already going to be in simplified form as a number. If it did, you would just multiply it by the 3 on the outside. But whatever. Anyways, so 2 to the 3rd power, 2 to the 3rd power is 8. Now multiply the exponent 2 times 3 for the x, so we get 2x to the 6th power. Do the same thing for the y, we get y to the 12th power. And that is your full, complete, final answer to number 13. Let's move that out of the way. Okay, so these are going to be the rest of the examples we're going to do. I want you to try each of them, at least number 14, and press pause and see how you did. Try number 14, hit pause. And that's what you get for number 14. Now, I'm going to briefly explain how to get that, so if you're not sure how, if you already do know how, you can press fast forward. If you don't, watch it. Like I already explained on the last one, it's everything on the inside to the 6th power. So you have negative 3 to the 6th power, and then just for the ones you already have a power, you multiply them together. Now, you would use your calculator to find out 3 to the 6th power, negative 3 times negative 3 times negative 3 times negative 3, and 2 more times. But long story short, a negative times a negative is a positive. So that means an even number of negative numbers being multiplied by themselves is going to equal a positive answer. So this is going to be a positive answer, not a negative answer. So then 3 times itself 6 times, you're going to get 729 positive with the calculator. Now, k to the 4 times 6, that's 24, and then m to the 3 times 6, that's 18. That's how we got our answer for number 14. Okay, now back to number 15. Hit pause and try it if you haven't done so already. Press pause. And that's your answer for number 15. Now, if you already know how to do it, you need to fast forward past this next part. Everything on the inside to the second power. 6 to the second power is 36. F is the 7 times 2, so f to the 14th. G doesn't have an exponent, so it's going to get that 2 from the outside for the reason, or just showing you work like this. And then h to the 6th power. 3 times 2 is 6. That's how we get our final answer for number 15. Okay, now try number 26 if you have not done so already. Press pause. Alright, you get negative 64 times k to the 3rd times n to the 6th times n to the 21st. This next part's me explaining it, so you can fast forward if you already got the correct answer. When you go to do everything to the 3rd power, everything on the inside of the 3rd power, notice you have negative 4 to the 3rd power. That means you have a negative number times a negative number times a negative number. Well, negative times negative times negative, that's a negative number. So that's why you're going to have a negative answer. Now, 4 to the 3rd power, 4 times 4 is 16. 16 times 4 is 64. That's where we get negative 64 from. And now do the same thing with the letters that we've been doing. And so we end up with k to the 3rd power, we end up with m to the 6th power, and n to the 21st power. And this is how we show our work. By the way, make sure you have all your steps shown for each of these. Alright, so the first thing we're going to talk about, or the next topic, is going to be negative exponents. There's 2 things you need to know with negative exponents. You need to be able to just do basic conversions with them, and some examples of those are what you see below. You also need to be able to do operations with them, and that's what we'll talk about second. So first, let's talk about converting them. As a brief reminder, essentially whatever variable or item, letter, or anything, whatever item has the negative exponent, that item moves to the other end of the fraction. So if you think you already know how to do 17, press pause for a moment and do number 17. So if we move it to the other end of the fraction, it's currently over 1. So if we move it to the other end, that means we're moving it to the bottom. So when we convert x to the negative 3 power to a positive exponent, it's not going to be in the bottom of the fraction. So it's going to be underneath x to the 3rd power. And on top, since there's nothing left up top, we're going to put a 1 there. So the answer is 1 over x to the 3rd power. Now press pause and try number 18, number 19. Or at least one of them. Notice, only the y had a negative exponent. So, I have a mistake in this one. The z should not have moved. Let me fix that. The z didn't have an exponent, so the z should not have been moved. So I put the z back on the bottom. So the answer should be x squared over y to the 4th times z to the 5th. Try number 19 if you haven't done so already. I went ahead and marked the items that had negative exponents, only they moved to the other end of the fraction. So it'll look like that for number 19. So make sure you understand what it means to convert, especially when if you have questions that say, perform this operation or simplify and express your answer using positive exponents. If you happen to get your answer looks something like one of these, you'll now know how to convert your final answer to a positive exponents. Now we're going to focus on doing operations with negative exponents. Sometimes we can have problems that have negative exponents in them. And so for each of these, make it also your goal to express your final answer as a positive exponent. So press pause and try at least number 20, but maybe try both of them. Hit pause. Remember how to multiply with common bases. You add the common terms. Add the exponents when you have common bases. So we have negative 3 plus 7. And that's going to give us x to the positive 4 power. So that means you're going to have to use your negative skills here as well. Now try number 21 if you haven't done so already. Press pause. Now, when you add a negative 4 plus negative 5, adding negatives, you're going to go deeper into the negatives. That's when it happen. So negative 4 plus negative 5, we're going to go deeper into those negatives. So you end up with x to the negative 9 power. So that is your final answer, but not your final answer. That is your answer, but it is a negative exponent, and I instruct you to express each of your answers as positive exponents. So if you don't remember how to convert this to a positive exponent, go back to over here, and on this slide we talked about it. So we're going to move to the other end of the fraction. We're going to be left with 1 over x to the positive 9 power. That's going to be the final answer, number 21. All right, try number 22. Press pause. And that's what we get for number 22. Negative 4 minus 7 is negative 11. Go deeper into the negatives, and you get 1, and then convert it to a positive. So you have 1 over x to the 11th power. Try number 23 if you haven't done so already. Number 23, you subtract anytime you're dividing with common bases. So you have 12 minus, and it's already negative 5, so it's 12 minus negative 5. So you usually remember how to subtract the negative. When you subtract the negative, you end up adding. So what we really have is 12 plus 5 is what we really have. And that's going to give us x to the 17th power. And that's going to be our final answer, number 23. So now we've done some examples of multiplying with negative exponents and some examples of dividing with negative exponents. Technically, you have power of a power of monomial with negative exponents as well, but we didn't focus on this too much. And you just use your imagination if you need to, but for the most part, we're not going that intense with it. So this is the gist of what you need to know. Or for the sake of showing you that it's possible, let's do a quick challenge question. It's going to be a power of product with negative exponents. So here's your question. Take all of this and apply what we've learned about negative exponents and the power of a product to see if you can simplify this all the way. So take everything on the inside and raise it to the third power. So this is your answer, and this would be the case, but notice we want you to express all your answers with positive exponents. So you're going to need to convert this answer so that you only have positive exponents. You'll notice the x has a negative exponent. Therefore, the x is going to be moving to the other end of the fraction. Everything's in the top of the fraction right now, so it means x is going to go to the bottom. And this is going to be your final answer. Lesson 6, we talked about how to convert into and out of scientific notation. So pick a moment, we're going to try each of these. For the first two, you're going to take that scientific notation and put it into standard form. And for the second two, it's already in standard form, but you're going to put it into scientific notation. So press pause and try number 24. You get 450,000. Now, essentially, that's because you're multiplying by 10 to the positive 5 power. That means you move the exponent, I'm sorry, not the exponent. It means you move the decimal to the right 5 spaces. So 1, 2, 3, 4, 5. Now, each of those empty blanks, they're going to get filled up with zeros. We have 4 blanks, that's why you see 4 zeros. So 450,000. Press pause, try number 25. Now let's be number 25. Now notice, you're going, because it's negative, you're going to be going to the left. You're going to go once, and then you're going to go 5 more times. So right off the bat, you know there's going to be 5 zeros between the 3 and the decimal place. So 1, 2, 3, 4, 5. So 2, 3, 4, 5, 6, and each of those blanks gets filled up with a 0. That's how we got that one. Press pause is number 26 and 27. 8.5 times 10 to the 7th, that's because the decimal is currently here. 3, 4, 5, 6. We got to move it 7 spaces to make it 8.5. So to put it back, we got to move it to the right. So because to put it back, when you move it to the right, it's positive 7, not negative. Hit pause and try number 27 if you have not done so already. And that's your answer for number 27. Because the decimal starts off here, we need to get it between the 9 and the 6. So 1, 2, 3, 4. We have to move it 4 spaces. But to put it back, we got to make it smaller. We have to move it to the left to put it back, and that's why it's negative 4. So these are examples of converting into and out of scientific notation. Now we're going to talk about doing computations with scientific notation. Alright, so now we're talking about computing with scientific notation. We're going to start off by talking about multiplying and dividing. And as a reminder, when you multiply and divide, you do not need quote-unquote like terms. By like terms, I'm referring to the actual scientific notation portion. They do not need to be the same when you multiply and divide. Just make sure that your final answers are in proper scientific notation form. So again, you do not need like terms. So you're going to start by doing it to the coefficient, then you're going to do it to the actual, use your exponent skills on how to multiply with common bases, use your exponent skills on how to divide with common bases. Alright, so press pause and give these a shot. Hit pause. So like I said, start by multiplying your coefficients. 3 times 4.2, do that first. Then use your exponent skills on the scientific notation portion. So we get 12.6 times 10 to the 12th power. Now, that is our answer, but that's not in proper scientific notation form. So we've got to take this decimal that's currently between the 2 and the 6. We need to move it once to the left. So we just went from 12 to 1. So we made it smaller. So if your coefficient, if your number gets smaller, your exponent's always going to do the opposite. It's going to get bigger. So this is going to turn into 1.26 times 10 to the 13th power. And that is the complete, final, proper scientific notation answer for number 28. Now hit pause and try number 29 if you have not done so already. Remember, do the coefficients first. So 2.4 divided by 4.8, and then do the 10, and then use your exponent skills and subtract the exponents. So if we do that, 2.4 divided by 4.8, well, that's going to be 0.5. And now 8 minus 5, that's 3. So you have 0.5 times 10 to the third power. Now again, that is your answer, but it's not in proper scientific notation form, so it's not your final answer. To put it in a proper form, we're going to move it once to the right so that there's one digit of 5 on the left. So we just went from 0.5 to 5, so we made it bigger. So if you make your little base, your little coefficient scientific notation number, if you make it bigger, you make your exponent smaller. They're always the opposites. So your final answer is 5 times 10 to the second power. That's your final answer to number 29 in proper scientific notation form. Now, if they wanted the answer in proper form, in just regular standard form, yeah, you could do 5 times 10 to the second power and get 500. But if you're going to put your answer in scientific notation form, here you go. So this was an example of multiplying and dividing where you do not need like terms. So now we're talking about adding and subtracting with scientific notation. Remember, these do need like terms, meaning you need to turn that scientific notation portion to the same number before you can do it. So an example of that is, you'll notice that our scientific notation portion, 10 to the 7th, is not the same as the 10 to the 5th. So we need to make them the same. I always recommend to you that you should take it's easier to take the bigger one and make it into the smaller one, so turning that 7 into a 5. So I didn't mean to give it away already. Hit pause and try this question. So yes, as you heard me say, the 7 needs to become a 5. So that means it's going to get smaller by 2. So that means if it's going to get smaller, this number always has to do the opposite. The number's got to get bigger by 2 spaces. So 1, 2. So that number becomes 340 times 10 to the 5th. And now the rest of it stays the same. You now have like terms, so now you can go ahead and add them. Now, as a heads up, when you do, your like term is going to stay the same. You're going to have something times 10 to the 5th power. So times 10 to the 5th power. Now you just have to figure out what is 340 plus 4. So 340 plus 4, well, hey, that's 344. So we're going to have 344 times 10 to the 5th power. Now, that is your answer. However, it's not in proper scientific notation form. The decimal's at the end. We're going to move it 2 spaces to the left so that it's going to become 3.44. And because we just made it smaller by going from 344 to 3.44, it means we have to make our exponent over here bigger. So that one got smaller by 2 spaces. We have to make this bigger by 2. So 3.44 times 10 to the positive 7 power. And that's your final answer for number 30 in proper scientific notation form. Alright, so here's your example of subtracting with scientific notation. Press pause, try this problem. Hit pause. Now as a hint, if you're still kind of confused, turn these into like terms first, then do it. So hit pause if that helped. So we're going to turn this bigger exponent, we're going to turn that 11 into an 8, which means we just made it smaller by 3 spaces. Since we made it smaller by 3, we need to make this number bigger by 3. So 1, 2, 3. So it's going to become 7200, so 7,200 is what it's going to become. So 7200, 7,200 times 10 to the 8th power. Then just drop everything else down. Now do your coefficients first, but as a heads up, the answer is going to be something times 10 to the 8th power. So I'm going to go ahead and already write that. Something times 10 to the 8th power. So let's find out what that something is. So we're going to do 7200 minus 8.4. So 7200 minus 8.4. That's what we're going to do, the two coefficients. And if you do that, you end up with 7,191.6 times 10 to the 8th power. Now, again, that is your answer, but it's not in proper scientific notation form. So we're going to have to take this decimal, we're going to have to move it over 1, 2, 3 times to the left. So it means we just made our number smaller by 3 spaces. So 7.1916. So I said 3 spaces, so that means our exponent needs to get bigger by 3. So times 10 to the 11th power. And that is our final answer to this question in proper scientific notation form. Lesson 8 was all about taking roots, such as square roots and cube roots. Now, a square root is something times itself equaling that number. So, for example, the square root of 36. You're asking yourself, what times itself equals 36? Take a moment to think about that and write down that answer. Press pause if you need to. What times itself equals 36? Well, that's 6. 6 squared, or 6 to the second power, that equals 36. So it means the square root of 36 is 6. Now, take a moment, hit pause, try number 33. Alright, square root of 121, that is 11. 11 times 11 equals 121. Now, for cube roots, I suggested to you guys for cube roots that if you need to, they're kind of guess and check questions. Feel free to make out a list of perfect cubes. Like so. Make out a list of all the perfect cubes. So, for example, 6 cubes, 6 times 6 times 6, that equals 216. So that means the cube root of 216 is 6. So we're asked for the cube root of 27 and 512. Use this list to help you find those answers. And if you do that, you'll notice the cube root of 27 is 3, and the cube root of 512 is 8. So these are exact answers to each of these questions. This was not an estimating. So another way of using square roots, very often you'll have questions where you're given the area of a square. And if you're given the area of a square, you can easily find the side length of the square. And to help you explain how, remember how to find the area of a square, you would take the side and raise it to the second power. That's because the length of the square is just a side. The length and the width are the same thing, they're both sides. And since the area of a rectangle is length times width, we would have side times side. Well, that's just side squared. So to find the area of the square, you would square the sides. But if you already know the area, you're working backwards. So to work backwards of knowing the area already, so if you know the area already, you're going to square root it. And that's going to give you the side length. So use that to help you answer each of these questions. So in this first question, let's say we're looking for the side length for the first question. And by the way, I guess that would make this number 36. The next one, 37. So for number 36, find the side length. Find the length of one side. Sometimes these questions might be phrased of something along the lines of, hey, you have a bunch of plants to set out. You have 625 plants. How long is one row of the plants going to be if you're going to put them in a square pattern? And in other words, you're asking what is the side length. That's a fancy way of asking this question. And for number 37, you're not just going to find the side length, you're going to find the perimeter for number 37. So press pause and try these. So number 36, if you know the area, you square root it to find the side. So that means the side length is 25 inches. That means this square is 25 by 25. That's the dimensions of this square. Now number 37, press pause if you haven't done so already. So the perimeter of that square is first find the square root to find the side length. But since we're asking for the perimeter, they're asking for all the sides. So that means all the sides are 15. So 15 plus 15 plus 15, or 15 times 4, find out the perimeter is 60 inches. That's the length around this square. Now, when we're estimating with roots, we're essentially going to find what whole number, what integer, in this case we'll just say positive whole numbers, is going to give us the close approximation to each of these. So when you do these, just look for one that is close to. So for square roots like number 38 and 39, it's as simple as just using the calculator if you need to, and just hit square root of 60 or hit square root of 105 and just round that answer to the nearest whole number. Now, for questions like number 40 and 41 where you're doing cube roots, not quite as easy. You're going to have to take that number since it's a cube root, remember that list you made hopefully of cube roots, and start to search and see what number is it closest to so you can figure out which one it is. So hit pause and try each of these questions. 60 is really close to 64, and so that means it's going to be closest to 8. And hit pause for 39. 105 is really close to 100, so that means it's going to be a little bit more than 10, but it's going to round to 10. I don't know why I wrote 100, so about 10. Now for number 40, hit pause. Alright, so look at your list of perfect cubes. That is definitely closer to 729 than it is to 512, which means it's going to be closer to 9. So the answer to that question is it's approximately equal to 9. Number 41, hit pause. Okay, 250. 250 is between these two. And you'll notice 250 is closer to 216 than it is to 343. Therefore, it's going to be about 6. That's the approximate answer for the cube root of 250. So this is what I mean by estimating with roots. So when talking about comparing real numbers, let's first make sure you remember and review all the different types of numbers. So your options were rational, irrational, and if it was rational, let's decide if it's also an integer or if it's a whole number or a natural number. So for each of these, name what each category is. Press pause and think for yourself what each types of numbers these are. Name all the categories they belong to. Press pause. Number 42 is just a rational number. That's because it can be written as a fraction, 0.5. Hey, that's 1 over 2. But also because it's a terminating decimal. If it's a terminating decimal, it'll be a rational number. Number 43, press pause and think about it if you haven't done so already. Number 43 is a rational number as well because it's technically over 1, but more specifically, it's an integer. So number 43 is a rational integer. So I'm going to abbreviate. Now hit pause to try number 44 if you haven't done so already. Number 44, you'll notice that decimal has a pattern. Because that decimal has a pattern, that makes it a rational number. So number 44 is a rational number. Now you just have to decide, is it also an integer? Well, it includes decimals. Integers are only positive and negative whole numbers, no decimals. So that means it is just a rational number. It is nothing else, nothing deeper. Now press pause and think about number 45 if you haven't done so already. Number 45 is a decimal that goes on forever. So it does not have a pattern. Therefore, it is irrational. The decimal goes on forever without a pattern. And as a side note, a great example of an irrational number is the square root of a non-perfect square. Because the square root of 10, for example, it's not going to be a pretty number. It's going to be a decimal that goes on forever. So the square root of a non-perfect square. So there's another one. Those will be examples of rational numbers. Another one is pi. It goes on forever without a pattern. So make sure you review the different types of numbers. Use your graphical organizer that we made in your notes. That thing is your best friend. So now we're just going to talk about how literally to compare numbers. So when you're literally comparing numbers, you're going to do something first. You're going to turn everything into a decimal. Sometimes it might be easy to turn everything into a fraction, but in general, turn everything into a decimal and then compare to see who's bigger, who's smaller. This can be used for simple questions where it wants to know who's greater than, or who's less than, or who's equal to, or it might want to know when they're wanting you to graph them on a number line and they want you to put them in order. So obviously you know who's bigger, who's smaller, so the ones that are smaller will be further to the left. The ones that are bigger will be further to the right. And so just make sure you're able to figure each of these out. Alright, so press pause and try these two questions to see if you can determine who's greater than, who's less than, or whatever, or equal to, and fill it in to make it true. Alright, you know that because if you actually hit the square root of 8, the square root of 8 comes out to 2.82. And then 2.8 repeating is 2.88. So you can tell clearly the alligator would rather eat the bigger one, the 2.88 over the 2.82. Press pause and try the next one if you haven't done so already. Alright, and that's number 47. Okay, so we've now run through a review of all the main ideas of Chapter 1. Now, of course, this wasn't exactly everything, but this was a pretty comprehensive review of all the main ideas. So make sure that you keep track of each of these topics. So improve the quality of your foldable so that you can reflect on each of them. So what we did is we summarized pretty much everything and make sure you're thinking about any mistakes you had. If there was a problem you tried and got wrong, make sure you maybe re-listen to that explanation. Or maybe if you see there's a topic you still don't quite understand, you need to go rewatch that video for that topic. So we did product of powers, we did quotient of powers, and then I explained some of those in depth. And then there was our examples of quotients. Okay, we talked about power of monomials. That included the skill of power over power, and that included the skill of power over product. You need the power over power skill in order to use the power over product. So in order to use the power over power skill, you need to know your product of powers. Then you need to know power over power in order to do power over product. So make sure you're practicing each of those. We did examples of each. Alright guys, just make sure you're studying, you're practicing, and you work on any topics you need. Take care. Hope this helped.